for recording purposes, we're doing transformations part 2. Last week was obviously part 1. And this is where our story starts up today. Remember, you are pretending to be a detective who goes to the cemetery to talk to spirits and ghosts. And usually the spirit and ghosts tell you their life story. Okay? Strange storyline, but what you gonna do? So let's see who we meet up here today.
You wait a few hours again and suddenly you see a ghost appear holding a glass bottle with a note in it. You walk up and introduce yourself.
All right, so you walk up to this ghost and the ghost tells you, "Good night, stranger. Would you lend a ghost like me your ear? My name is Elizabeth and I was born in the year 1666. So she's dressed like a pirate, right? So most likely the story is going to be involving a pirate, right? But how did she end up in the cemetery? Why does she wander the cemetery? We'll find out. All right, so today's first question, there's no need to draw it. You just need to provide answers. Last week, I remember doing a reflection in the X and Y axis. And I also remember doing some special graphs. Remember, the horizontal line is your x-axis. I'll just write it in here. And this black vertical line, not the red line, not the red line, the black vertical line, that's your y-axis. Now, last week we were doing reflections in the x-axis and the y-axis, and we had discussed a couple different methods of reflecting in the x-axis or reflecting in the y-axis. You could have used the common sense method, or you could have used what? Matrices, okay? Right? Right. So, but today is going to be a little different. Look at the first question. They want us to do a reflection in the line x is equal to -1. Remember how that special graph looks in maths? X equal to -1 is a vertical line, and that's the red line. I already drew it in for you. It's a vertical line going through what on the x-axis? You notice it's slicing the x-axis at -1. Now, in the exam, if the examiner were to give you a shape like this one, this is a quadrilateral, and asks you to reflect something in the line x is equal to -1, most likely the examiner is not going to draw the red line for you. He is not going to draw the line x is equal to -1. You will have to remember that x equal to -1 is a vertical line going through -1 on the x-axis, and you get 1 mark for drawing that red line. Now, when you want to reflect something in a line that's not one of the standard lines, like an x-axis or a y-axis, unfortunately, you have to use a kind of common sense method. Remember, how does a mirror work? If you are standing 2 meters away from a mirror, then inside the mirror, on the other side, or inside the mirror, you look like you are standing 2 meters inside the mirror. In other words, the distance from the mirror on one side is equal to the distance on the other side. So let's do this question, right? I will do one of the points for you. I'm going to start off with point A. If point A is on this side of the mirror, remember, we're pretending the mirror is the red line. Let's figure out how far A is from the mirror. So we start at A, and let's count the amount of blocks. 1, 2, 3, 4, 5, 6. It's 6 blocks away from the mirror. So that means its reflection will be the same distance on the other side. Now, right now, the coordinates of point A, let me just write it here, is minus 7, 5. It's written here. On the other side of the mirror, once it hits the mirror, if it's 6 blocks on this side, then it will be 6 blocks on the other side. So let's start counting from the mirror. The mirror starts here. 1, 2, 3, 4, 5, 6. We're not paying attention to the y-axis. The y-axis is what? Not the mirror. The mirror is the red line. So if it's 6 blocks on this side, it will be 6 blocks on the other side with reference to the red line. And of course, you get point A prime now. What's the coordinates of point A prime? We can read it off now. It's 5 on the y and 5 on the, 5 on the x and 5 on the y. So its coordinates now, A turns to 5, 5. You think you all could do the same thing for point B? Start at point B. And of course, count how much blocks it is on this side, and then it will be the same amount of blocks on the other side. I want you all to send your answers for B, C, and D. Well, B prime, C prime, and D prime. Get the coordinates of the reflection, of the reflected image. Good luck. And of course, I like it when you're sending answers on it. I'll see if I use a different color for B. I'll use blue. So B starts here. And B is how much from the mirror? 1, 2, right? It's 2 horizontal blocks from the mirror, which is the red line. So that means on the other side, it will also be what? 2. 1, 2. You're counting from the red line. 1, 2. So I think B prime will end up here. And this looks like 1, 5. 1, 5. So the original B was minus 3, 5. And when it got reflected, it became 1, 5. And I saw a lot of people had that answer from me just glimpsing at the chat there, right? Take a few seconds with C and D, not more than 30 seconds. Look out C and D. For C, I think I'll use green. He's also how much from the mirror? 1, 2. So that means on the other side, he will be 1, 2. C prime seems to be 1, 1. So the original C was minus 3, 1. And when he got reflected, he was 1, 1. Let's do D, right? D is how much? 1, 2, 3, 4. And then you hit the mirror. So he will be 4 on the other side as well. 1, 2, 3, 4. And he looks like 3, 1, right? So D was, the original D was minus 5, 1. And now he becomes 1, 1. Right? And of course, I don't need to ask if people got it correct because I've seen plenty correct answers on the chat. So if I take my marker now and connect all 4 points, doesn't it look like it got reflected? Remember, a reflection is look kind of opposite. This one, the nose facing this way, and in this one, the nose facing the other way. The mirror does always make something look opposite, right? So obviously a very common question would be, well, how much marks do you get for something like that? This in the exam, you might just get, for something simple like this, you might just get 4 marks. I can't see you getting more than 4 marks in the exam. So sometimes they might be a little stingy and you might only get 3 marks, right? You get 1 mark for drawing this line here, x equal to minus 1. And you get 2 marks for filling out the 4 points, okay? So don't expect too much marks for something simple like this. But it's still marks, right? Right, so take a 20 seconds, reason out what you did wrong, right? Reason out what you did wrong if you got it wrong. And we will be moving on. moving on. Okay. Right? Remember, the mirror is not the actual y-axis. When the mirror is the actual y-axis, I gave you all 2 techniques last week for reasoning that out. This situation is different from last week's situation. Let's move on, right? Right. How about this one, guys? You want to do a reflection in the line y is equal to -2. Remember, y equals to -2. It's a horizontal line going through -2 on the y-axis. Remember, this is your y-axis and this is your x-axis. We are not reflecting it in the x-axis. Instead, we are reflecting it in a line below the x-axis. And the name of that line is y is equal to -2. This time, you're counting the distance, the distance below the mirror. So if it's 2 blocks below, the reflection will be 2 blocks above. Once again, it's the same concept. The original object and its reflection are equidistanced from the mirror. You think you all could do this simple question for me and send the answer? You don't need to draw it. You just need to put your eyes close to the screen, use your fingers to kind of figure out the coordinates, and send your answers on the chat. Right? You will not get more than 4 marks for this in the exam, I guarantee. Right. A is here. A is how much right now? A is 3 minus 4. And he's 2 blocks below the mirror. Now, common sense would say the reflection will appear above the mirror in this particular case, on the opposite side of the mirror. And how much blocks is he from the mirror? 1, 2. So that means on the other side of the mirror, he will be 1, 2. So point A actually ends up on the x-axis. So last week I showed you how to write out a point if it's living on the x-axis. So his point is actually 3, 0 because he's living on the x-axis. The x value is 3, but he doesn't have any y value. So its y value is 0. Okay? For point B, he is also 2 blocks below the mirror. 1, 2. So that means above he will be 1, 2. So I forgot to put a little dash here. Prime. He is also living on the x-axis. He is 10, 0. I'll give you all a few seconds for point C. Count how much block C is below the red line, which is the mirror. Okay. Let's count. I'll use a different color for C. I'll use green. C is down here, right? So the original coordinate, that's on point B. Put the answer is 10 minus 4, and B prime was 10, 0. Sorry about that. Let's do C now. C is how much blocks below? 1, 2, 3, 4. It's 4 below the mirror. So that means it should be above the mirror by 4 also. 1, 2, 3, 4. C ends up here. Well, C prime. And his coordinates looks like 10, 2. So the original is 10 minus 6. And now he is 10, 2. And of course, if you take your ruler and join up these points here, doesn't it look like a reflection in that red line? You notice this one, the nose pointing up, and this one, the nose pointing down, right? So something did look the opposite. And of course, a little bit of imagination would have told you, hey, the reflection should have looked like that. Okay? Great. Look for your mistakes, right? Remember, if you're using a phone, it might be kind of hard to see properly. But if you're using a laptop, I know you could put your eyes real close to it. You could use your fingers to count the blocks and whatnot, right? So I would advise when you come into class, use a PC or a laptop, or if you have a tablet, right? If possible, right? So how much of you all think that in the exam, you could get this? All right, so let's see Elizabeth's story. So she's telling you her story now. See a little pirate ship there. So let's see what's going on with her.
Elizabeth had been a pirate aboard a ship called the Devil's Dutchman. While at sea, one of the Queen's English ships attacked them. During the battle, she was thrown overboard as the English vessel sank, having lost the fight. They rescued her from the water, but only to punish her for her pirate ways.
Right, so it seems Elizabeth was a pirate on the English quarter, right? Not out of sympathy, but because she's a criminal, and well, criminals get punished, right? All right, we are continuing with Elizabeth's story, and let's see what happens to her. All right, a reflection in the line y is equal to x. Now, if you turn back in your notes that you were supposed to have made last week, how much of you all remember this special line? Y equal to x. If the examiner were to say, to draw y is equal to x, how much of you all could genuinely say, or you could see in your notes, that y equal to x is a diagonal line sloping upwards? In other words, this line here is y is equal to x, right? It should be in your notes, right? You should have it in your notes. Now, to reflect something in this line, y is equal to x, it's a very simple, there are two ways you could do it. You could use the matrices method, but we're not going to do that one yet. Or you could use a kind of common sense approach, the easier way. So let me just give me a few seconds to write down the original coordinates of A, B, and C. Coordinates A is -2, 1. Obviously, when it gets reflected, it will change into A prime. Right now, B is how much? -2, 4. When it gets reflected in y equals to x, it will change to B prime. C is -8, 4. C prime is this. According to the instructions, and you have to remember this is the kind of common sense way, right? Whenever you are reflecting an object in the line y is equal to x, here's the instructions in yellow. The values of x and y coordinates are switched. Real super easy. Meaning that if the original coordinates of A is -2, 1, remember the first one is x and the second one is y, right? The first one is always x, the second one is always y. All they are trying to say in the instructions is that you switch the positions of x and y. In other words, the y goes here and the x goes there. So in other words, A prime will be what? 1 - 2. I just switched the positions. I didn't even change no signs or nothing. I literally take up the x, throw it where the y is living. And I pick up the y and I throw it where the x is living. So let's plot this point. The new point, A prime, is 1. Well, if here's 0 and here's 2, 1 will be in between, right? 1 will be in between 0 and 2. 1 - 2. So this is A prime. 1 - 2. You think you could do B and C for me? Just try it. All you're doing is following the instructions, right? If you think it's easy, it's because it is super easy. All right? Some people think everything in maths has to be hard. Not everything is hard, right? Not everything. Send the answers for B prime and C. When we take the second way of doing it, like I was saying, if you don't want just to switch X and Y, and if your teacher says, hey, you have to do the reflection using the matrices method, we're going to take the matrix that you're supposed to memorize, that will perform a reflection in the line Y equals to X, and we're going to multiply by point A, which we wrote vertical. Number 1 swings up to the top, just like last week. The -1 and 2 are on top now. You photocopy it here, photocopy it, sorry. You photocopy it above the top numbers, and you photocopy it above the numbers below. Each pair, you are going to do what? Multiply. You're going to multiply each pair. Anything by 0 is 0. 1 multiplied by 1 is 1. 1 multiplied by -2 is -2. 0 by 1 is 0. To get the answer on top, we add the two final values on top. 0 plus 1 is 1. -2 plus 0 is -2. You notice we got the same answer? Look at it. They just switched around the values. The underneath number went on top and the top number went underneath. It did the same thing as the previous slide. And I guarantee you, if you take this matrix and multiply by B and C, it will be time consuming, but you'll get the same exact answers as before. Like I said, I'm not going to make you do all of it. That's pretty redundant, okay? Right. But be careful in the exam. And like I said, the examiner could tell you which method to use. Teachers like to stress which methods to use, right? Me too. I'm just like that, right? Let's move on to the next slide. Right. You think you could do this one for me by following the instructions? They just say you could follow the instructions. I want to see everyone getting the hang of how I wrote the instructions. This time we are doing a reflection, not in the line y is equal to x. Look carefully. It's y is equal to minus x. That's when the mirror or the line slopes the opposite way. You have an original triangle, A, B, and C, right? Don't use the matrices method yet. I want you to use the easy method, the one in the yellow box. It says that, that's someone, right? It says to do what? The values of x and y coordinates are switched and their signs become the opposite. Let's just see if you could follow my instructions. I'm going to read it back, although it's in front of you. The instruction says if you are reflecting in the line y is equal to minus x, you not only switch the positions of the x and y, but you make each one the opposite. In other words, you change the sign. If it's negative, it becomes positive. If it's positive, it becomes negative. Send your answers across for A prime, B prime, and C prime. So the original A point is no, we got a different color there, is -6 minus 2. Look it down here, -6 minus 2. According to this, we not only switch the positions, but when you jump to the new position, their sign will become the opposite. So right now he is -2. So when he jumps over here, he becomes +2. And -6, when he goes to his new position, he becomes +6. They are switched and become the opposite signs. Point B, he is -2 minus 2. Well, when they switch and make the signs the opposite, you're going to get +2, +2. For C, which is -2 minus 4, look at here, -2 minus 4. They switch and become the opposite. +4, +2. Let's plot this. We're going to plot A prime, B prime, and C prime. 2, 6. B prime, 2, 2. C prime, 4, 2. 4, 2. When you join this up, that's your reflection in the line y is equal to minus x. Once again, y equals to minus x is a slanted mirror. So predicting the answer in your head, it's going to be kind of difficult, right? Because I'm sure no one predicted that the triangle will be facing upwards. The nose will be facing upwards. Okay? Prove it. So once again, if the examiner asks you to use the matrix C method to do a reflection in the line y equals minus x, we have to take the matrix C we're supposed to memorize, and we're going to test run it in point A, which is minus 6 minus 2, and let's see if we get the same answer. So the minus 2 swings up to the top. So we have two values on top now, minus 6 and minus 2. Photocopy it to the top, and photocopy it underneath. Each pair, we are going to multiply each pair. And by now, everyone should be good with negative numbers because you're, because you all started the, I hope you all came the Saturday maths class to kind of brush up on positive and negative numbers. Anything multiplied by 0 is 0. Minus 2 multiplied by minus 2 is positive 2. Minus 1 multiplied by minus 6 is positive 6. And anything by 0 is 0. To get the answer on top, we add the two final answers on top. 0 plus 2 is 2. 6 plus 0 is 6. You all notice? It switched the two values and it made the values the opposite sign. It did the same exact thing as the yellow note, right? Let's get ready. Sorry, we'll give everybody a few seconds just to look at it, just in case they made a mistake, and we will move on to the next slide. Let's see what's going on. Well, we did that. All right.
The English marooned her on a desolate rock, with no island or land in sight. She dared not risk swimming in search of salvation, knowing it would be futile. Despair settled in, until, by chance, a bottle with a message floated toward her, offering a glimmer of hope.
All right, so let me explain what's up. Usually when pirates got caught as their punishment, they would maroon them or desert them or on a rock or isolated island, right? As punishment. Now, she was lucky a bottle came up to her. I didn't get to put the audio in for the second piece, but I'll read it for you guys. The message in the bottle was from a shipwreck, another shipwreck sailor, and it even contained a rough map indicating where he might be. The location seemed close. With nothing to lose, Elizabeth threw caution to the wind, diving into the water and swimming towards what she believed was the right direction. Well, she has nothing to lose. She's going to swim and see if she can find that shipwreck sailor.
She eventually reached the island after swimming for hours. When she reached the shore, she was so exhausted she passed out on the sand. Later she was awakened by the abandoned sailor.
All right, so it seems that she found the sailor. Right? But unfortunately, no help ever came for Elizabeth and Captain Christian, right? Well, that's Captain Christian there. But they did spend 28 years on the island together before the island started experiencing frequent tremors. So I guess you all could predict what's going to happen very, very soon. All right, so we'll see what happens in a little while. right? The values, okay, here's what. There's another one called a reflection in the line, sorry, about the origin. Sorry, not about, well, where do I have it? Did I write it? Something is blocking my view, right? Right. So there's something called a reflection about the origin. I want you to turn back in your notes and see if you could find this matrix. Make sure you could physically spot it. Whenever the examiner asks you to do a reflection about the origin, right? It's a specific, that's exactly how he will phrase it. There are two ways you could do it. You could multiply all the points by this matrix, or the values of x and y remain in the same position, but the signs become the opposite. I want you to do this question, but I'm not going to make you do the matrix method. I want to see if you can follow the green instructions. Everyone send the answers for A prime, B prime, and C prime. Remember, the x and y values staying in the same position. You're not moving the x and y, but you are making each one the opposite sign. Good luck, and let's see if we can produce the answers for A, B, and C prime. I'll write them back in here, -2, 1, in case you can't see it. -2, 4. I'm just copying back these values here. -4, 4. Got the hang of it? Remember, the -2 and the 1 staying in the same position. It's just that the -2 becomes +2 and 1 becomes -1. 2 -4. 4 -4. Right? So I believe most people got this one correct, right? You can also get it correct by multiplying each point by the matrix, the special matrix, but let's bypass that today. The first point is 2, 1, 2 -1. Next point is 2 -4, 2. That's what was I blocking here? 2 -4, that's B prime. And C prime is 4 -4. Right. Something looking wrong here. I did something wrong. No, it's correct. It's correct. It looks correct. It just, I wasn't able to imagine the answer for this one. I got a little brain freeze there. But that's your answer. All right. Let's get ready to move on. Let's get ready to move on. Remember, when you get a chance, you have to watch back the video and make super good notes. Draw back all the graphs and everything. Right. So we're going to do something called enlarging an object. Enlarging an object means to make the object larger. We have all done this. When somebody sends you a picture, let me say somebody went to a party and they send you a picture, and sometimes you just take the picture and zoom in on it, and it just make the picture look larger so you could see things in more detail. Making an object larger, which is to enlarge an image, is the same thing as zooming into an image. And I want to show you some of the calculations your phone or your computer has to do in order to enlarge an image. So here we have a triangle, right? A, B, and C. Let's just say, right, that we want to make this triangle 3 times as large. And the examiner says, hey, you need to show, you have to use a graphical method to do it. In other words, he wants you to use a ruler and a pencil to make it look 3 times larger. Now, whenever you are making something larger, the examiner has to tell you the point of enlargement, right? So, or the center of enlargement. In this question, the center of enlargement is the origin. You have to read the question real good, right? If the center of enlargement is the origin, you have to pretend you are standing up by the origin. I'm going to put a red dot over here. Isn't that the origin? I'm putting an arrow here. You have to pretend you are standing there. And here's what you're going to do. You have to read how much times he wants you to make it larger. In this question, it's 3. So when we're done, right, our triangle should look 3 times as larger. But it will be, you can't draw the triangle 3 times larger at any point on the graph. It will end up on a specific point on the graph. So here's how you're going to do this. What you're going to do, let's follow the steps here. Let's see if I get a different color. The first thing is that you have to connect a point to the origin. So let's see which point I'm going to connect to the origin first. I'm going to start off with point B. It doesn't matter which point we do. You see what I did? I take my ruler and I connected B to the origin. And what you have to do, when you draw the line, you have to measure it with your ruler. Let's just make up some values. Let's say that this red line, when we connected B to the origin, let's say it was 5 centimeters. I'm not too sure how long it is, but let's just assume it's 5 centimeters. If you're making it 3 times longer, then you see the 5 centimeters, you have to extend it by another 5 and by another 5. The first 5 counts as 1. The next 5 counts as 2, and the next 5 counts as 3 to give you a factor of 3. Let me show you. I actually animated it for you guys. So you see the original red line that counts as 1. We use our ruler. We extend it by another 5. That's 2 5s, right? The original 5 and the new 5 centimeters. And then we put another 5 centimeters. Anybody wants to tell me what's the total length of that red line? Just to make sure you're following along. What's the total length of that red line? What's the total length? It has to be 15, right? From here to here is 5. From here to here is another 5. And from here to here is another 5. When you see an enlargement of factor 3, you have how much of the lines? 1, 2, 3. All right, the first one counts as 1. And then you have 2 more extensions to bring it up to what? 3. So that means C prime will end up over here. So C prime will end up where? By 12. Let's not write it. Will end up by 12. Hold on. 6. That looks correct, right? That looking like 12, 6. Let's take another point. Let's take point. Look, I took point C and I connected it to the origin, right? Point C is connected to the origin. That's the blue line. We have to measure the length of that line. Let's just say when we use our ruler, the length of the line was 2 centimeters. We would have to take that blue line and extend it 2 more times. If we do that, look carefully here. We're going to take that blue line, put 1 more extension, and then put 1 more extension. If the original part was 2 centimeters, then the full length of that blue line is now 6 centimeters. So that means C prime ends up over here, which is 3, 3. And we're going to do the same thing for point A. Connect point A to the origin, measure the length of that line. You all see a green line there. If the length of that line was 4 centimeters, I'm just saying if. Then you have to extend it by another 4 and another 4, making the total length 12, because 3 by 4 is 12. One more extension, one more extension. And that takes us up to here. Right? Sorry about that. I need to go back 1 second. Right. So point C prime ends up by 3, 9. And if you connect all new points now, C prime, sorry, that's A prime, my mistake. If you connect A prime, C prime, and God, I'm making a mistake here. This is supposed to be B prime, my mistake, guys. Right? If you connect A, B, and C prime, you will get this large triangle. Does that triangle look 3 times larger? You'll notice it's like you're shooting laser beams out from the origin, and each laser beam gets 3 times longer. Okay? Right? Is there a way to prove that this triangle is 3 times larger? Yeah, I have a real easy way to prove. If it's 3 times larger, then each side should be 3 times as long. Look at this. From A to C, look at it. From A to C, how much blocks is from A to C? 1, 2. From A to C is 2 blocks. And then from A prime to C prime is how much blocks? 1, 2, 3, 4, 5, 6. If it went from 2 blocks to 6 blocks, and 6 is 3 times larger than 2, so you just test run one side of the triangle, and it seems that one side of the triangle got 3 times as long. So common sense would say, well, if that happened to one side, then it will happen to the rest of the sides. Okay? Now, the thing that students get wrong, right, is that, let me show you what people used to do by mistake. If you're making it 3 times larger, you see the original line, like I'm going to put it in black here, the original line from the point to the origin, some people forget to count that as 1. Now, we know the correct thing to do is say the original line is 1, the next extension is 2, and the next extension is 3. What some people used to do by mistake, the original line, they forget to count it. So then they say the next one is 1, the next one is 2, and then the next one is 3. If you do that and you forget to count the original one, well, then you would have enlarged it by 4 by mistake. The triangle would have been 4 times larger by mistake. Okay? You have to count the original. And that is what this note is about. So if they told you to enlarge it by a factor of 2, I'm just saying if, then the original line would be 1. And then when you extend it one more time, that would be 2. All right? This is a lot to take in, but I guarantee you see when you're watching back the video, the second time and you have that graph paper in front of you and you're drawing it back neat, it will fall into place. Right? Is there another way to do an enlargement by a factor of 3? Other than drawing it, like taking a ruler and what? Measuring the length of the lines individually. Yes, there is, right? There is another way to get the same exact answer, right? We'll get to it just now, though. Let's see what's going on this island here. So you're on the island.
With each passing day, the tremors grew stronger, more violent. It was clear the end was drawing near. They had lived a long, full life, and though they had made peace with their own fate, a deep sorrow clung to them. Their hearts ached with the unbearable truth. Their son's life, so young and full of promise, would be stolen far too soon.
All right. Let's see what's going to happen on this island.
One morning, they were jolted awake by a deep, thunderous rumble. Stepping outside, they saw the sea had vanished into the horizon, pulled back for miles. They knew what was coming. With no mountains to climb, no shelter to flee to, and the island far too small to offer safety, they walked to the shore and stood hand in hand, waiting for the inevitable wave to claim them.
The ocean retracting. You all know by now what happens, what it means when the ocean retracts, right? Huge tidal wave rushes towards them. I think that's the end of them, guys. There's nowhere to run. The tidal wave swallows the island. But that's not the end of the story. There's plenty more to go, right? Right. So, is there another way to do an enlargement question? If they told you to enlarge this triangle by a factor of 2, and once again, they said assume the center of enlargement is the origin. Instead of drawing lines from each point, like we could do it like this. We could take point A and connect it to the origin. This is the origin, by the way, right? 0, 0. And we can measure the length of this line and then do what? Like, let's say the length of this line was 7 centimeters. If it's an enlargement by a factor of 2, then we just have to enlarge it by 1 more centimeter, 7 centimeters. 1 7, another 7. That's a total of 2. This question is different from the last question. The last one was an enlargement of 3. This is just a simpler one, an enlargement of 2. And you would do the same thing for the rest of them. You would connect B to the origin. You would measure the length of that line. Let's just assume, right? Let's just assume it's 8 centimeters. Well, then it has to be another 8 centimeters to get it to be an enlargement of 2. And of course, you do the same thing with point C. But let's say the examiner tells you you cannot use the drawing method. Well, there's an enlargement matrix. If you look back in your notes from last week, you can perform an enlargement, and the matrix is K, 0, 0, K, where K is the enlargement factor. So in the last question, if they told you to enlarge it by 3, then you would replace both K's with what? 3. If they told you to enlarge it by a factor of 2, but then you simply what? Erase both K's and replace both K's with 2. And then you would just simply take this matrix and multiply by point A, by point B, and point C. And you will get the answers for A prime, B prime, and C prime. Y'all want to try one for me? Let's try one for me, no? Let's say you take 2002, and I want you all to multiply by point A. A is 1 minus 2, right? Take this matrix multiplied by A, and you will get A prime. And A prime, you will get the same answer as if you had used the drawing method. Do me that favor, no? Take A multiplied by 2002, get the answer. And you will realize, wait now, we would have gotten the same answer if we were to draw it. Right. How much of y'all got this answer? 2. I'm not going to work out this, right? I think everyone should have gotten the hang by now of multiplying matrices. You're supposed to get 2 minus 4. 2 minus 4. Right? Not minus 2, but positive 2. Right? And I guarantee you, if you use the drawing method, it would have ended up down here by 2 minus 4. Right? Right. So just to point out, this formula only works if the center of enlargement is the original, this formula. right? And I'm going to try to trick you later on, right? I'm going to give you a question and I'm going to ask you to use the matrix C. But the center of enlargement is not going to be the origin. And people are still going to use the matrix C, right? Yeah, that's completely wrong. The matrix C, once again, can only be used if the center of enlargement is the origin, and the examiner has to make that super clear in the exam. It has to be written somewhere. Okay? Let's go. Right. Look at this question now. Enlarge A, B, C, where the center of enlargement is minus 1, 3. Well, what's the scale factor here? Right? Let me get the points A, B, and C. I know it's kind of hard to see. Let me just write it back. Point A is 1, 0. I know it's hard to see. B is 3, 0. And point C is 3, 1. We want to enlarge it by a factor of 3. What do we all agree that if it's an enlargement, remember it's K003, right? How much of you all agree that this is the matrix C we have to use to enlarge it by a factor of 3 for this question? How much people agree? 3003. How much of you all agree with that? That that's the correct formula to use? Anybody? I'm trying to trick you, right? This is obviously a trick. Because if you read the question properly, the center of enlargement is not the origin this time. They're saying the center of enlargement is this point P here, minus 1, 3. I know the numbers are kind of small, right? Sorry about that. But the center of enlargement is not the original, is not the origin this time, right? It is not the origin this time. So, in other words, you cannot use the matrix C method this time. You cannot use the matrix C method this time. The only way to get out this question is by the drawing method. So what we need to do, we need to connect all of these points individually to P, measure the distance, and then extend it 2 more times, right? You have to extend it 2 more times. So let's do that here, right? Let's try this. We're going to connect. Oops, I should not do this on 1 second, guys. Right. We're going to connect point A to the center of origin, which is point P. So you're using a ruler, you connect it. I know I kind of did it fast here, but you notice, like if this original line here, let me just say that was 5 centimeters. I'm just saying if. Then the total length of this line would be 15, because 5 plus another 5 plus another 5 would be 15. If this line here was 6 centimeters to point B, like we take P and connect it to point B, if that was 6 centimeters, then the full length of the line in that direction would be 18. And the same thing goes for the other one. Now, when we connect these 3 points, your triangle will look like this. It will look 3 times larger. And the whole thing looks like a laser beam is being shot from point P, right? And we can see it's 3 times larger. Look at this line here. This side is 1 block. And in the new triangle, it's 1, 2, 3. One side got what? 3 times longer. Y'all think y'all understand this one, right? It's the same thing, except the center of enlargement is a different point. It's not the origin. And when the center of enlargement is not the origin, you cannot use the matrix. You have to use the drawing method. The matrix is only used for an enlargement when the center of enlargement is the origin, nothing else. Okay? Right. Let's go. Yes, now, guys. I just had to get just give me 1 second. I have all right, let's continue this story, right? Let's get the audio.
Many years later, a ship arrived at the deserted beach and made a haunting discovery, the bones of a family, lying side by side in eternal rest. It seemed that even death could not tear them apart. The crew quickly realized these were not the remains of island natives, but of souls from the old world. With reverence, they gathered the bones and carried them back to England, where their story would at last be remembered.
All right, so let's see what happens. I love that piano music, by the way. That creepy piano music. I don't know why.
The bones were eventually sold to a museum, where they were put on display behind glass. Over the years, they drew countless curious eyes, cloaked in an aura of mystery. Who were these three souls? What fate had brought them to such a distant shore? The questions lingered, unanswered, turning their silent remains into a timeless enigma.
All right, let's move on. All right, so sometimes the examiner gives you a reverse question, right? It gets a reverse question. You all notice that let's call the smaller triangle the original triangle. I'll call it point triangle A, and the other one triangle B. Is this an enlargement? Let's say the original triangle was A and the next triangle was B. Is it an enlargement? Does this look like an enlargement question? And if so, anybody think from just looking at the diagram, they can figure out the enlargement factor, like how much times the triangle got larger? It's a simple question, not even a trick question. By just looking at the two triangles, how much is the enlargement factor? Right? Take a guess. Right. It's obviously an enlargement factor of 2. You could just look at the triangle and compare their sides. Like this side here, how much blocks it is? 1, 2, right? 2 blocks. And triangle B, the same corresponding side has 1, 2, 3, 4. If this is 4 blocks and this is 2 blocks, isn't 4 twice as big as 2? So the enlargement factor is 2. But where is the center of enlargement? Remember, knowing the enlargement factor is not the only thing. Where is the laser beam being shot from? Right? Right? There's a real easy way to figure out the center of enlargement. Let's just call this point A and this A prime. I'm going to write a little better. Sorry about that. Let's just call this A and this point A prime. Let's call this point B and B prime. Let's call this C and this C prime. All you need to do is connect similar points, like connect A prime to A, and just use a ruler and go to the end of the graph paper and do the same thing for B. Take B, connect it to B prime, and using a ruler, go to the end of the graph paper. And then using C prime, connect it to C, and then go to the end of the graph paper. All three lines will meet at a common point. It's like you're tracing it backwards. But obviously my drawing is terrible. Let me use the computer to do it. If you connect two similar points, you notice I connected this point to its similar point. And I not only connected it using a long ruler, I went to the end of the graph paper. And then I did the same thing for the other points. I took this point and connected to its original point. And I'm going to do the same thing for the next point. You notice all 3 points come together at this particular point. What's the coordinates of that point? 4, 5. Look at it. 4, 5. That is the center of enlargement. It's kind of like you're just backtracking everything, like you're going back in time. You're tracing back the original point. Okay? That is how you find the center of enlargement. Okay? To me, this is the easiest question to do and the funnest question to do in this particular topic. It has backtracking the lines. Okay? Now, when you're doing the homework, make sure and draw this back neatly and use a ruler. You can't do this with a short ruler. You need the long rulers to do these particular questions. Never, ever, ever a short ruler. Okay? Let's move on. Right? We'll save this one for next week, right? I think you all have a lot there, a lot to process. Let's see the end of this story now. Remember, this is Elizabeth, right? She wasn't really a good person for part of her life, right? But let's see what happens to Elizabeth. A very sad ending, kind of sad, but...
While her husband and son were welcomed through the gates of heaven, Elizabeth was denied entry. Her past as a pirate, marked by unspeakable deeds, barred her from joining them. Yet, the fires of hell did not claim her. Instead, she was sentenced to wander the cemetery in twilight, banished for 1,000 years. Only after serving her time would she be granted the chance to reunite with the family she loved and lost.
All right, so that is why Elizabeth wanders the cemetery. She's just biding her time for 1,000 years. Right.
You can see the horror and sadness in Elizabeth's eyes as she recounts the story.
All right, so that's the end of the story there, guys. That is the end, right? So I hope you all enjoyed the story, right? And of course, you all have some homework to do, right? So make sure, guys, watch the recording, make super, super good notes, and come fully prepared for next week. And of course, if you know anybody who wants to join the program, every time I will ask, because every time I ask, I get new people to join, and it's because of you guys helping me out. Just tell anybody who wants to join to WhatsApp me and say fish. That's all they have to type in the WhatsApp message, fish. And I will add them to the program. Okay, guys. So I hope you all had some fun today. And next week, I hope you all are ready for next week's story of horror. And I hope you all find my stories interesting enough and not cheesy. All right. Take care, guys. Have a good one. See you all, some of you all for English class. And tomorrow it have physics. And the day after is chemistry. Blah, 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 blah. All right. Take care, guys. Have a good one.